Good afternoon. As Dimitri said, my name's Tony Egan. I do work for Glencore, but in the immersed world, which is an industry in-kind body, I've been involved since day one, and we've got 20 years of immersed happening this year. So it's been quite a long time and a number of topics. In this particular topic around vehicle interaction, been heavily involved since probably about 2013. So it's been an interesting journey. One of the things we're doing is providing resources to the industry, and we'll talk more about that at the end of today to show you the industry resources that are freely available for you to use. But one of the things that's coming up a lot is not about technology, it's not about individual things, it's actually about, at a mine site, how do I get started to get change happening around this exercise? How do I then implement things? How do I work with providers and those sorts of things? So today is being driven around what's the process that we followed and what were the hurdles that we overcome and what were the things that really challenged us along the way, and how did they come out for us, which I'm proud to say was a very successful project. So I'd like to introduce Neil Pollard. Neil worked with me on that project at Glencore and is continuing on as the operational technology manager and implementing thousands of these units that we developed in that original process. In concert with that, Professor Robin Burgess-Limerick from the University of Queensland. Robin's worked with the mining industry for many, many years in a range of areas, particularly human factors. And Robin, we commissioned some research back in 2017-18 around the audible and visual human factors aspects about the interfaces that our operators use. So he's going to cover some of that, and it'll become a very important piece of the project that we did. And Craig Hoffman. Craig's the technical engineer for Wabtec, has a long history in this space, been involved with many evolutions of things. But Craig's going to talk from the Wabtec perspective about what did they have to change? What did we drive them to change? What were the things that occurred that made this different, that succeeded in an outcome where we hadn't succeeded previously? So we've got some questions. A little panel thing here. So just quickly, what's immersed? A global safety by design initiative. Really what we're trying to do is close the gap between what we need to, in terms of our expectations in managing the problems that we face every day, and what we actually get from the OEMs, what we actually get out of the factory. And the last 20 years has been about trying to close that gap, and in particular on some key fatal risk topics. So what are the industry challenges? I'm going to have to look up here because my eyesight's not that good. We've done a lot of work in this space, and this is the feedback out of some recent industry get-togethers over this topic, and that recognising that silver bullets are not the answer. It's about having all your underlying systems in place and let the technology actually, oh thank you, you've increased the size. Let the technology actually complement those underlying controls. But if you've got an expectation that I've got problems, just go get some technology, it's going to solve everything, it's not going to happen that way for you. And we've seen lots of examples of near fatalities and other things where people thought they were protected and they weren't. Maintaining a balance between people and equipment and process. That really encompasses that whole thing, that it's about having a balance between everything. So the technology needs to work in concert with that. The variability caused by bespoke use cases. Heard a lot over the last number of years that, oh no, we're different. We're a different commodity, we're this, we're that. Well, we've got to a point now, 13 years down the road in this space, where everyone's agreeing, and we're running a program through the ICMM in London with all of the leading tier 1 miners that are members of that, and they're all sitting there going, oh yeah, actually we've got the same problems and we've got the same issues. So therefore, if we can come together, that's going to accelerate the way that we can introduce change. Because as a provider, and I'm sure Craig will talk to this, where you've got all these bespoke solutions coming at you, which one do you pick? Maybe you pick none. And that's going to hold us all back in terms of development. And the last piece is that technology integration with an effective baseline, and that's what I was talking about, having those underlying systems in place that protect you every day. I mean, we had an incident on a site last week where it's standard in the design to have physical earth barriers at the middles of intersections. They weren't there, and a truck could cut that corner, and it did, and ran straight over the front of a light vehicle. By the way, that site has level 9 vehicle interaction intervention systems fitted, and the incident still occurred. And it's a classic example of not having effective underlying systems in place and monitoring the performance of those. The technology still didn't provide the mechanism to save us. I'll keep going through some of this stuff, but it more talks about the way that we operate. I'm keen to get onto the questions, but it really, what it's saying there is that the designers themselves are good designers, but they're not good users. We're good users, and as engineers, we often think we're good designers. But the reality of what Immerse brings up is that we've actually got to come together. They need to understand our use cases and the functional performance parameters really, really clearly. And we need to understand the constraints about what they're offering us, and not thinking it's just this, nirvana thing that they're going to buy and fix everything. And today is really about talking about that path that we went through. So, Neil, 3 questions for you. We'll start off with the first one. What did the journey to CAS implementation really look like for Glencore?
So I guess it probably goes back about 10 years, I guess. So it was really about doing our baseline assessment. You can learn a lot about the baseline assessments and those sorts of things through the Immerse website. But as Tony was talking about, just making sure those fundamental controls that you already have at your sites are in place and working and are proven, and just improving those sorts of things from road design to training to equipment design, those sorts of things. So that's sort of level 1 to 6. If you jump on the Immerse website, you'll see the levels, but ultimately your sort of fundamental controls, make sure they're in place. So we did those baseline assessments through Glencore in 2015. Probably around the same time we moved to hierarchy of control as well. So we were in New South Wales traffic rule. So big change to the sites was implementing hierarchy, which was a good step change for us. But we continued to have incidents. So I guess in 2019, we went out to the market, did a world search, went around the world, looked at many, many different technologies. And to be honest, we thought that most of the products that were out there, none of them really suited. They weren't sort of functioning at the performance level that we were looking for through functional and performance requirements that we'd written in Glencore. But we felt that there was one that we could partner with and develop and get that product to a point where we felt that it actually achieved what we felt that it needed to achieve. So, and then I guess the development with Wabtec was scheduled for 9 months, but COVID came along and supply was difficult, and getting resources to site to do practical testing of the equipment was tough, and that turned into a 3-year journey ultimately. But yeah, it was a huge collaboration, and to have a host mine site to go for such a long period of time, work through all those iterations of the software, etc. It was pretty tough times.
You said a minute ago that we went in with a set of functional performance requirements, but talk about the reality of that we really didn't know what we didn't know at the beginning, did we?
Yeah, I think if we had our time again, we'd probably rewrite those functional performance requirements. So we sort of went in with a list of maybe 100 specs in there, and some of them would be written differently today, and certainly I agree with Tony, like we didn't know what we didn't know, and once we sort of started testing the product in the paddock and those sorts of things, yeah, that would have been very different.
I think I was more alluding to when the storyboard development occurred.
Yeah, I can talk.
Which was a collaborative exercise.
Yeah, I can talk to that. So I guess it started with PR5A on the Immerse website, but that sort of moved into all the different types of vehicle interaction scenarios that you can have, and there's myriads of them. But then morphing those into storyboards, or ultimately like animations, like piece by piece, how does this interaction play out with the particular vehicles? And that was a real game changer for us to be able to tell the story to the designer ultimately. And because for us, as Tony was saying, it was us about being able to clarify what the problem is to the user or to the developer, and then actually them go and solve that problem. It's not up to us to solve that, but we really needed to clearly define the problem accurately. And the storyboards, which are ultimately started out as a PowerPoint presentation, I think really gave clarity to the vendor on how to solve those particular interactions that we were looking for.
And what about the role that industry played in validating those?
You could probably talk better to that than I, Tony, but yeah, I mean, ICMM and Immerse were part of that. PR5A was a big help for us in developing those storyboards as well.
I think the key thing around these, what we call functional performance storyboards, so you've got scenarios like there's a T intersection. As a designer, it's like, yeah, that's a T intersection, but how far, how fast, what distance? You need all the functional performance parameters. What the functional performance storyboards have encompassed is to pull all that together so a designer can sit there and say, okay, now I understand the scenario, and these are the sort of things I need for my design. But what we did in that period was, through the Immersed and other parts of the industry bodies, we actually threw the storyboards out to everybody and said, we think we're onto something here. what do you think? And so two things happen. One, someone will break it on you, and that's great. You learn quickly and you move on. Or two, they go, no, actually you're onto something here, and then they start throwing their horsepower behind it. And so, all these years on, that was 2019, we've now got a published set of the functional performance storyboards. They're not perfect, but they're industry agreed. And so everyone's saying, hey, if we follow those, and in recent times we've developed an underground set that have been very widely collaborated on around the world. So as a provider, and Craig can talk to that a bit later, but I think that's a really important piece for you in terms of investing in time. So Neil, maybe moving on to the next one. So we got through that design piece and everything, but the challenges became bigger in terms of the workforce and that engagement process.
Yeah, 100%. So keep the workforce on the hook for 3 years was pretty difficult. Getting them involved, and the version controls and the different software that we rolled out was tough, but it was all about feedback. I think going back to the design phase, Tony, we had some really key members in that working group down in the office at Wabtec, doing that development. We had a mine manager, we had a couple of operators that were multi-skilled, digger operators, dozer operators, trucks, etc. The mining superintendent, we had the system engineer. So a really good cross-section from the mine actually be involved sort of straight up when we're still in the classroom, ultimately, sort of working out the storyboards and those sorts of things. So having those guys and girls involved was pivotal to actually understanding what it was that we needed to solve. Once we actually started getting the stuff on the machines and turning the screens on and getting them to have a first look at the software, that feedback from the workforce was really, really important, because very quickly they tell you where you've got it wrong. They're pretty good at telling you what's right too, but they love to tell you what's wrong. And I think that feedback was really important. So keeping them engaged, making sure that they were heard, and that all the issues that they brought up any given day, we investigated, we provided that feedback loop to the operators around, well, this is what we look at changing, etc. I mean, we had 3 goes at turning the screens on through that sort of, 18-month period or 12-month period that we were turning screens on. And when we first turned the screens, I absolutely hated it because the thing alarmed all the time, everywhere, at every speed, and the feedback was unanimous that it was just over-alarming, was too much for them, and to the fact that if this is going to continue, we're just going to end up ignoring this thing. So, version 2, version 3, we worked through it and got it to a point where they're like, oh, this is really awesome. It alarms when I need it to, and it doesn't when it's not important. So, and then right at the end, I guess, just to wrap up that point, Tony, I think what was really important and pleasing for me in the fact that we did manage to keep them engaged through that whole time, that we did a whole of site survey at the end as well, really targeted survey about, it was a bit of a wrap up. What did they think of the system? Has it helped you in any scenarios over the last 12 months, etc.? And there was some really positive feedback from that compulsory survey at the end that we'd hit the mark. We'd got an outcome.
The previous mine sites around, we're in the Hunter Valley, so it's a very small community and everyone talks to their mates at the pub. So there was a lot of cynicism, and I think there's an old saying about you get to make a first impression once. We had 4 goes. So, and we had to manage that really carefully the whole way along, and people need to understand that, hey, this thing isn't perfect. We're developing it, and you're a key part of that process. So just wrapping up then, Neil, in terms of, it's been now 5 years, or nearly 6. What's been happening since we wrapped up the development in 22, 23?
Yeah, so we're on a full surface operation deployment at the moment, so as Tony alluded to, thousands of units, about 2,500, 3,000 units across 5 surface operations in Queensland and New South Wales. So we've sort of gone into that execution mode now, I guess. A lot of the development that we did at the Glendale trial has held true, so there's not been any changes to the logic or how we've got the system configured. And Glendale was a fairly small pit where we did the trial, so no double side loading, no drag lines, so we're now implementing at sites where there are different vehicle-to-vehicle interaction scenarios, but we actually haven't learned anything new. So the core logic and programming and configuration that we've come up with has actually held true at those sites, which has been pretty amazing.
Just touching on that, I mean, you hear about configuration a lot, but there's a big difference between getting the logic right and configuration. Do you want to talk about that? Because that was a 6 to 8 months experience for you and Holly particularly.
Yeah, as I said before, when we first turned screens on, we try to get everything all the time, but the reality is these systems just over-alarm when you try and do that. So we really peeled that back, and I had the vision that we're probably not going to get everything all the time, but we need to get what was important. So for me, it was around fatalities and injuries. So if we had a high consequence interaction that resulted in a fatality or an injury, then absolutely we want to capture that all the time. If we have a bit of metal on metal, some other stuff, because the trouble with these systems is that we interact closely all the time in the mining industry, right? We're reversing underloaders, we're interacting with dozers, all these sorts of things. That's just normally how we operate. But these systems struggle with that because we're so close, the vehicles are so close to one another. So to sort of change the configuration and sort of configure our way out of that, ultimately, to detect what's important, high speed, high consequence types of incidents, but maybe not ignore, but sort of silence the other interactions that are probably not as important. You can still see them on the screen, but maybe you don't get an audible feedback to that. So highly configurable, and sometimes you can disappear up your own, sometimes when you're configuring these systems, but that's that balance that you have as well.
But if the logic's wrong, you can't configure your way out of that.
Well, if the sensing's wrong as well, right? So if you're using the wrong sensing suite and you're not got the right sensors, and then you've got the logic on top of that. So the logic's got to be right to then be able to configure the system. So there's sort of 3 key aspects that you've got to get right.
So just wrapping up then, you're rolling out across 11 sites? 9 sites,
yep.
About 3,500 units.
Yep.
In a fairly quick program, over a short space of time. There's been some challenges around underestimating implementation issues, the fitment, the time it takes to get the gear fitted. Maybe it's quickly touch on that.
Yeah, look, installation does take its time. We subcontract out there installations. That's taken a bit of time. I think the way we've gone slow to go fast. So installs with screens off, we're learning. So we've got a lot of data in the background without having that feedback to the operator. So you get a bit of a baseline assessment on where your interactions are up to before you actually even turn the screens on. And then turning the screens on over a period of weeks, because you can't turn 100, 300 or 400 screens on in a matter of days. So you do that in a staged approach. And then you have this sort of soft go live where you've got this period of bedding in. The operators are getting used to it. You're getting feedback from the operators, maybe about particular interactions or hardware defects or whatever the case may be. And then once the site's sort of comfortable with it and got their own processes, because you actually got to embed it into your own ecosystems at site, which is a huge undertaking. And then at that point, you sort of drop the boom gates. Compulsory that contractors use the portable units, and you sort of got this go live date ultimately. So we've sort of stretched our programs out, a lot of learning rather than going, we'll turn the screens on and the next week, that's it, we're done. We've sort of stretched that out over a period of weeks, and that's been really good.
And you've got the alarming rates down to a level that's not normalising the operators. When they hear it, they act. And,
yeah, absolutely.
And I think the other key thing that I've seen out of it is that the operators are starting to identify physical changes in the mine based off those. They know that I'm getting this alarm and I shouldn't be. What's changed? And we've seen problems with road widths and all sorts of things. So it's you can see the forest for the trees now. Whereas when we looked in 2019, if you're getting 20,000 alarms a day, you can't search your way through it, and you're down to a pretty acceptable level. Going to switch gears onto Robin. So I introduced Robin. We did what's called ACARP, Australian Coal Research Projects. We funded a program that Robin ran, and I think it's been really beneficial. At the time when we did it, we didn't really see where we were going with it. But when we actually brought it into this project, it really made a difference. So, first of all, what is that human-centred design, Robin?
Yeah, there's a couple of different levels to human-centred design. One is to say we want to design a system, and in this case a technology to avoid collisions, with the people in the system in mind. And that's more than just the users, so it's more than just the people in the cab. They're certainly a big part of what you're trying to design for. And those functional specifications that Tony and Neil mentioned, a lot of those were written from the point of view of different people within the system. So what does the operator of a truck want out of a system? What does a light vehicle operator want from a system? And what does the supervisor responsible for the safety and productivity of the site want? And what perhaps does the maintenance manager want from such a system? So those are the one way of looking at human-centred design. It's designing from the point of view of all the people who will be affected by this system that's being designed. The other way of looking at human-centred design is something that Neil alluded to, and that's having those people involved in the design process. And the design process is iterative. It's not that you do it, get the specifications, design a prototype and roll it out. That's the way it works. No, that's not the way it works. Inevitably, there is a cycle of we take specifications, we revise those, check, do a prototype, take some more information, iterate and iterate. User testing, oh, that's still not quite right. Back to then we look at the details of how to modify the parameters and so on. But at every stage in that process, the people involved in the system need to be involved. And at times you might need to bring in some human factors expertise. And we'll talk about a little bit about what that might look like. But those two parts, there's two parts to human-centred design, and one without the other isn't sufficient.
So more specifically in vehicle interaction, I mean, situational awareness is the fundamental key to managing a lot of this stuff. So I might just flick on.
Yeah, so flick to the bit of video here. So yeah, so situational awareness is a concept that was coined by Mika Endersley many years ago. Essentially, collisions are caused almost always by a loss of situation awareness. So it refers to the understanding that a person has of the environment around them and things within the environment, or it could indeed be the state of the equipment. If your brakes failed, for example, knowing that that has happened is part of knowing your awareness of the situation. But usually we talk about it in terms of the environment around. There are three stages in Mika Endersley's model. The first is detection of stimuli. Usually visual stimuli, but not necessarily. Could be auditory, could be olfactory. Oh, there's a strange smell. I don't know what that is. I better investigate. But usually visual or auditory. So that's detection. The next stage is perception. And by perception, she means taking that set of stimuli and understanding what does it mean? What does that imply about the environment around us? Now, from the bit of video here is from a simulation study that Daneely, who's sitting at the back, is driving a simulated haul truck. We had control over the other vehicles in the simulation, and so when the truck passed a certain spot, a light vehicle approached from the right. Now, if you get the geometry right, the light vehicle image can hide behind the A-pillar of the truck. So that's a loss of situation awareness that has occurred because there's no stimuli there. That failed at the detection stage. So the aim of a collision avoidance system in that context is to provide additional information, additional perceptual information, so that the operator can be aware of the approaching light vehicle. Now, the next step to situation awareness is prediction. The aim of detecting the stimuli, understanding what it means, is then to predict the likely future states. And based on the likely future states, that's when a person makes a decision and takes action. So there's some key things there. Is the decision needs to be made in a timely fashion for the situation awareness to be effective. You can have accurate situation awareness, but if it takes you too long to achieve that, and you've missed the moment to take action, then in a sense that's another way situation awareness can be unsatisfactory. And so designing for situation awareness means designing to support perception and prediction, not just a beep that says there is something around you, you better have a look, but rather providing information which directly specifies the layout of other vehicles in the surroundings in this case, or even helps you with the prediction and action, and an auditory alarm that says brake is a way of supporting situation awareness, which is much more effective that we've found through the research than an auditory beep. Now, the third question, do you want to move on? Or
we might move on. I mean, really important thing is when you start to get your head around what Robin's talking about, this is the challenge. I think the biggest challenges that we faced in this whole development project was actually determining very specific situations, then identifying a specific response, getting that response to the operator and narrowing the potential human error in terms of how they respond. And that was a body of work that took, we thought it was going to take 9 months. I mean, that piece of work was nearly 12 months in itself. And we've not seen anywhere around the rest of the industry that we've seen work done in that space. But fundamentally, in 2019, when we went around the world and assessed everybody, the fundamental principle of the human interface was beep and look at something. That was the engineering principle. Didn't matter which system you looked at, it was like beep and look at something. When you actually get into the human factors stuff, in a lot of situations, the worst thing you do is take people's eye off the road because you're taking away all these sensors that you want them to function with. So it was actually counterproductive. So that's been a big challenge. So to that end, Robin, the unintended consequences piece about new technologies is really important.
Okay. And I just thought of one extra thing I wanted to say about designing for situation awareness. In almost every case, the biggest thing that can defeat a system is nuisance alarms. So designing for situation awareness also includes reducing the number of nuisance alarms to practically zero. Otherwise, the system is inevitably going to be unsatisfactory to the users, and if it's unsatisfactory to the users, it will fail. But unintended consequences, these can be positive or negative. It can be good things that arise or unintended negative consequences. One thing we can be sure of is that introducing new technology will change behaviour, sometimes in unexpected ways. But understanding and knowing that new technology will change behaviour, also one consequence is that you can't reverse time. You can't unscramble the egg. Once the new system has been employed, you can't then say, if you don't like it or there's some technical issues, oh, well, we can continue to run the truck because that's the way we used to and that was satisfactory. People have changed. So now that's become a safety critical system, you can't then go take it off without very carefully thinking about how that would be done. So I won't say never, but that's one example of a consequence. Other consequences, in the underground context, for example, where you're talking about pedestrians interacting with heavy vehicles, I have a concern that if you put a interlocked proximity detection system on vehicles operating in proximity to people underground, I have a concern that the pedestrians' behaviour will change because they'll say, oh, that's going to stop for me. We've seen that in the surface, that people driving out in front of autonomous trucks because they believe they're going to stop, and they do most times, but yes, they do every time so far. But it will change behaviour, so those consequences can be unintended. There can be positive sides too, so the information that's been derived from these systems can be utilised now to give improvements in productivity through choreography or ensuring that the interactions between light vehicles and loaded trucks, which you want to keep going, don't happen. So can we change the way the system works? Or as Tony mentioned, find out from the system where things have changed where they shouldn't have. So where our roadway standards haven't been maintained. So those were not intended consequences, but they're certainly positive benefits.
One key thing that the law provides that says how foreseeable was a particular incident. And when you're talking about these unintended consequences, we often look for the positive, what's it going to do? But we've also got to look for what can it do that we don't want it to do? And then how can we put things in place to not let that happen? And I think that to me has been probably the greatest concern that I've seen in the last 12 years in this space, is that people are putting these things in, they really haven't understood those unintended consequences. And when they occur, they go, oh, what happened? I didn't really think about it. And people go, oh, well, it's human behaviour, it's not foreseeable. Well, the work we did in this project with the good group of people, you can foresee these things and you can start to preempt them. And a lot of that went on in that period. I'm going to move over to Craig because we're really starting to touch into this was the challenge that we threw at you guys. This was all very different and a lot of new stuff. So the first question, Craig, is, you've been involved in PDS for a long, long time. And I certainly remember working with you, and this was pretty challenging for you personally, because you'd been scripted in the work you'd done and all the things. And I saw you change through that process. So maybe you can tell us a bit about how that went for you.
Yeah, I did. Oh, nice and loud. Yeah, I guess we've been providing PDS technology solutions for many years, but we'd never had a collaborative project of this nature where jointly we developed detailed functional technical performance requirements that addressed a problem that was clearly defined from Glencore. Not just chasing symptoms, not just chasing a technology solution as a band-aid, but clearly identifying the problem that drove detailed technical functional performance requirements. Across our business, I think we estimated, Mitch, we had about 100 people involved, either directly or indirectly in this project. It covered all aspects of our business, our engineering team, our software developers, firmware developers, hardware designers, mechanical designers, our product management team, our certifiers, our field service teams, product support engineers, procurement, manufacturing, project management, commercial. It impacted our whole business. It was truly a strong collaborative project driven by clear requirements, specifications that were developed jointly through a lot of the workshopping on site. We've talked about the functional performance storyboards. Everything was defined from an end user perspective, designing vehicle interaction solution from an operator's perspective. And we've heard about the operator engagement through this whole process, that every time we did a new release, every 2 weeks on a software sprint, we'd have our developers riding in haul trucks, seeing the new functionality, getting the direct feedback from the operators, feeding that back to Glencore, revising, optimising, tuning the effectiveness of the different scenarios that were implemented. So the level of collaboration was the best we've ever seen, driven by clear customer requirements. I remember the very first meeting you had with our key designers. Tony said, Wabtec, this is a zero-beat project. That was the challenge you put out there. Our previous products and the technology's come a long way. Yes, be a lot of beeping and a lot of buzzing, having to look at the screen. It was quite clear this was the big challenge. This system will only generate voice alerts when there's a potential fatality interaction, giving the operator the specific context of the threat and the mitigating action required to avoid a collision. So that was a huge challenge, only to alarm by exception, and needs to support production. And the huge challenge of managing this product development project through all the challenges of COVID-19 over a 3-year period.
I still remember, Craig, when we pitched the idea about the development approach, and your VP at the time, he was a Canadian gentleman, and he pulled me aside in the hallway afterwards and said, Tony, I can only fathom the millions of dollars that we've wasted thinking we understood the issues and that we were designing for. And I think it was Spencer, one of your developers. He was sitting next to one of our truck drivers one day, and Spencer had been doing the coding. And he said, oh yeah, blah, 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 it works this way. And the truck driver turned around and go, no, it doesn't work that way. And he went, really? You know, so you've got to come together. If you think that they're the technology provider and they're going to know how you operate, they don't. And vice versa. We don't understand. And the more we understood how you guys operated, the better we got at it as well. So I'm just going to move on to the next question, which is, in terms of key challenges and learnings, I think you've touched on a little bit of that, but it was a pretty significant organisational shift for you guys. And we didn't just challenge you about the technology, we challenged you about your delivery systems, the maintenance strategies, the training. You know, we came up with a joint approach. So over to you, mate.
Yeah, I guess from the technology perspective, in terms of that zero beep challenge, obviously that drove the front end, the sensing technology, in terms of we clearly understood up front we needed high precision GNSS capability. High precision that was standalone, not required RTK corrections, etc. To give us that sensing accuracy, the ability to differentiate between those safe and unsafe interactions on both straight roads, curved roads, those close interactions on loading and dumping, etc. So I think we identified we needed at least a metre accuracy, footprint to footprint, and that drove the selection of the sensing technology. We looked at, again, using all satellites 50 times a second so we could address curve scenarios. Our rules engine, taking that sensing data, had to have a lot of flexibility in terms of bringing in context, not only the local object, but the remote object. The speed difference of the remote object, the rate of change of closure, the safe state of the remote object, bringing all that extra context into the rules engine to make an intelligent decision. Is this a dangerous interaction that would then generate that voice alert?
Just to clarify too, I mean, that high precision discussion was one where we learnt from you guys and went backwards. And I went to our CEO and said, if we're not prepared to pay the extra money, so as customers, we have to step up as well and say, we've got to pay for high precision. But I said to our CEO, if we don't do the project. We're wasting our time. And our hypothesis was that we could cut nuisance alarming by having close tolerance performance by 65 to 70%. The day we turned on the base system, it was more closer to 80% of the nuisance alarms disappeared. And it was purely due to, if you've got low precision, you need big tolerances, so you're going to have a lot more interactions because of the way the system works. So Craig, we need to move on a little bit more. What's changed for you guys in the result of this? I mean, certainly from my first interaction with your sales guy in about 2018, 17, it's been a big change.
Yeah, I guess this whole collaborative project really highlighted the importance of clearly defining the problem. As a technology solution provider, understanding the problem from the customer, the end user's perspective, that then drives the development of technology solutions that address real-world problems, in this case, vehicle interaction risks, that our customers love, the operators, the end users, that deliver significant value to our customers' operations, and proudly that's what's been delivered through this project. Also, we've, again, as a part of this project, I guess triggered some user forums that we're implementing globally with our customers to get that feedback, the opportunities to refine and improve and optimise our current solution. I guess, again, we provide these technology solutions beyond Glencore globally around the world. So being aware of the key implementation success factors, we've heard about the importance of the alignment with the Vehicle Interaction Improvement Guide, the importance of key stakeholder engagement, change management, operationally integrating the technology into the existing systems and processes, etc. So absolutely fundamental in terms of knowing how to successfully integrate technology solution on those existing baseline controls. We have had a whole variety of continuous improvement opportunities to our product as a result of this project in terms of improving the reliability of our hardware, in terms of the service and support tools we've had to develop, whether it's configuration management of software, to optimise our installation times through kitting and pre-assembly where possible. Improving our training programs, the quality of training program delivery. So yeah, a lot of ongoing continuous improvement. The product continues to evolve and improve and change into the future. From a sales education process, yes, we still see many requests for quotes, proposals, tenders where customers are clearly aren't aware of the great work that Emerst has done in this space. So it's an onus on our commercial team to train these mining houses, go and look at the Emerst body of knowledge to understand what you're asking for. And yes, we've had requests, just give me level 9 intervention control, that's all I need. With understanding the importance of the baseline assessments, making sure that's mature before you start looking at a technology solution as a silver bullet. So
building on Robin's comment about that, the Mick Ensley model, I hear people say, oh, I'm getting a level 9 system, and I look at them thinking, you have no idea what you're talking about. Because if you can't do 7, which is the sensing, and then 8, which is the really perception and interpretation of the situation, then you can't do 9, because the only difference between 8 and 9 is you send a signal to an operator at 8, and you send it to a brake pedal or a slow down at 9. So we've got a lot of educating to do around the world in terms of people just jumping off cliffs like lemmings, thinking, oh, just buy this technology, it's going to solve all my problems. And the one other thing that really came back to my mind when we were speaking is our CEO, when we started down this path, and I asked him for more money for the high precision, and he said, Tony, you've got to work out the right thing to do and then get it for the right price. And I think in this space, I would say, be careful. If you're buying on price, you'll get what you get. But if you need to start to educate yourself, and that's what Emerst is trying to do, is enable people to ask better questions. We're not trying to pick a winner, whether it's Wabtec or another product, we're not trying to pick a winner. But what Emerst wants you to do is, whatever company you're working with, whatever situation, that you've actually taken the learnings that everyone else has stumbled along and scraped their knees and skinned their knuckles, so you don't have to. And I'm going to switch gears here because we've got some, where this is leading is that we've got some opportunity for a few questions. We've got some time, and we wanted to sort of get through the things. Eve's got a mic, and so is Holly up the back. So if you want to put your hand up, if you've got any specific questions of any of us, please just put your hand up. Looks like you're too good, guys.
We've answered everything, obviously.
Is there anything that, look, we've put some challenges on here. I mean, is anybody, think that we've not got those challenges right? Are we saying things that are in the wrong direction? No? No? Nodding audience? Come on, guys. Someone's got to have something to say. No? All right. What about you three? We've got a couple of minutes. Is there anything before we move on to resource materials? Do you want to, anything else that comes to mind from?
No, I think, again, it's like I said, it's been a unique situation for Wabtec to get involved in this significant collaboration development. Just the fact that we achieved our project objectives through the challenges of COVID. We all remember those days. We don't want to see them again. Component shortages, particularly around computer chips, a huge challenge, trying to spin off a new electronic design. All the social distancing and lockdown, we had to be flexible in our testing, engineers locked down at home, creative ways of actually visiting their colleague, doing vehicle-to-vehicle interaction testing while complying with the lockdown, the flexibility of installation programs due to social distancing, all those challenges we managed to stay focused on the objective and work through. For two large corporations like Wabtec and Glencore to pivot and be flexible was quite amazing through this process.
Yeah, it certainly took a lot of coverage in terms of keeping you guys out there and keeping the management at bay, because we did tell them it was going to take a year.
Yeah, so as you were talking, I was just thinking one of the things that I have seen be the enemy of human-centred design has been schedule, and we have a schedule to meet. And I was just wondering, do you think maybe actually COVID helped by being a really good excuse for things to take longer so that you had more time for that human-centred design process to play out?
I think we were outcome focused, not
Yeah.
we were outcome focused, because
Okay.
it wasn't we were just buying something. We in the contract we had. If it didn't work, we could walk away for $1, and they take everything off. So for us, it was achieving those outcomes.
Okay, so maybe that's the lesson then, is that to not let schedule dictate outcomes, because I have seen that in different contexts, is the engineering takes a bit longer than we thought it would, and sorry, we haven't got really any time left to look at those pesky human issues. We've just got to roll it out the door because that's what the schedule says.
Robin, just on that, Neil, remember the guy on the service cart, the very animated yeller and screamer guy? Could have easily been dismissed. I mean, maybe talk about that, because there was some pretty important stuff came out of that.
Yeah, I think I agree with you, Tony, and to the team, that we weren't driving to a timeline, we're driving to an outcome. And the fact that we had time to do, because we went and we did a lot of classroom work around the human-centered design user panel. Like, we reinvented that user panel, really. Like the colours and the way that it talked to you, etc., was an amazing amount of work. But then when we actually got it in the field, the operators were like, I really like to have speed, or I want to see my beams all the time. We didn't have the beams on the screens initially, but they wanted this yardstick, right? So they could see their beams. So that iterative process and that feedback from the workforce, we just took our time with that and settled it down. And yeah, to your point, Tony, there were some fairly animated characters about what they wanted the screen to do, and as part of that was also this particular gentleman was about the ergonomic assessment of where, because we've got a lot of screens in our cabs, right? It's just, I mean, you can count 5 to 7 screens in most machines nowadays, particularly loading units, and this guy didn't want, so CAS for us takes pride of place. It's classed as a bit of a critical system, and like the VIMs or whatever else on a cat truck, sort of takes prime of place rather than putting it up here or here somewhere where people can't see it. It's not in their vision. So he was adamant that he didn't want it in this particular spot, but we spoke through the reasons why that it needed to go into that place, and and sort of we ended up compromising and moving another screen for him. It was a bit of a balance, but just being, and for me, I'm a visual leader, so I like to be out in the paddock, and we were on the ground a lot through these 3 years, and getting in the cab and having those discussions with the operators around explaining why the screen needs to go there, and look, we'll make it a compromise, we'll move this screen, and having those conversations and bringing them on board and bringing them on the journey, I think. So it's really important.
I mean, a lot of our operators may not be well educated, but they're smart people, and they may not be able to articulate things at times, and they feel a bit threatened. I'm dealing with the engineering guys, but you've got to look past the behaviour, and you've got to listen to them and delve into it, because those guys are the thinkers. They've connected this and that, and if that happens and this happens, and they see stuff that we don't see. And I think too often we just go, oh yeah, it's just carrying on, move on. And I think there was a number of things that came out of those interactions.
I think the point there, Tony, is it's their office, right? So you're coming into their office, they sit there for 10 hours a day in their office, and then you want to shove a screen in that beeps at them every 60 seconds or something. They get pretty...
That nuisance alarming comment earlier, I went way back. Someone said to me, I had a provider actually say to me, so what's an acceptable level of nuisance alarms? And I went, 0. And he said, what do you mean? I said, well, if I put a thing in your car and it carried on at you driving down the road, would you find that acceptable? And he was like, oh no. I said, well, what are you standing here asking me that question for? We've got to go away and work out how we get 0 nuisance alarms. And that was really the thrust that drove us through this process. I might just flip over for a sec, because we might come back, but I said earlier that all the way along this project, we kept testing what we were doing with the industry through Immersed and other bodies. And no one person's ever going to have the answers, and the more you can engage people early and get them to think about things, they add terrific value. And so what we've ended up doing through this process is we've put together a whole body of knowledge, we've called it, that's the learnings that go back beyond our project, Roy Merley's work in South Africa in the underground space, and a whole range of other companies have come together to validate this work. So there's a website, Immersed. There's a QR code that'll get you there. Across the top in the yellow bar is the major topics that we're working on. I said earlier, it's all about fatalities. So right now it's vehicle interaction, tyres. We don't get it wrong in tyres very often, but when we do, it's generally fatal, unfortunately. And the other one is fires, which is quite significant. When we've started collecting, the industry started collecting the data, and it's amazing in that space how many we've had. So they're the 3 main bodies of work, but if you click on the vehicle interaction tab, it'll come down body of knowledge. And what you'll see is this screen here, which is an interactive page. And what this follows is the process that we've been talking about. If you follow it anti-clockwise, you start out, treat vehicle interaction improvement as a project, and it is a major project. It'll touch all sorts of your business, like Robin was mentioning earlier about all the different roles. And it's really important that you get it set up early, because there's going to be some hard challenges along the way for the management in terms of some of the decisions. And if you haven't got alignment at the beginning, we've seen people come unstuck when you get to those big decisions. The operational baseline, I mentioned earlier about what is it that you actually have in place today, the things that your underlying management system stuff, that provides a structure to reduce exposure in the first place from unwanted interactions. You can do that baseline. There's a validation process under the operational effectiveness there, which is actually really, it's not a risk assessment, it's not an audit or a compliance thing. It's a mirror to put up in front of yourself, say as the ops manager at a site, and say, how effective is what I'm doing, and am I really comfortable with it? And that process is pretty confronting at times. We've got ourselves over the last 30 years in management systems very tied up in lots of paperwork. That process cuts through a lot of that, and it's really quite stark. When you realise that I've got this fatal exposure, and I will have got some pieces of paper and a few things that people have to follow, am I really comfortable with that? Once you get through that, you can see, hey, how can I improve my baseline as it stands today? And Neil talked about, we did fatigue, that was one of the underlying loss of controls. We changed the road rules to hierarchy. We put cameras in light vehicles to monitor the driver behaviour. Pretty cheap things and pretty quick things, but we actually monitored the change in our performance. And we saw a change in the exposures. So when we actually got to do the CAS work, we actually understood the gaps that we had. We weren't after the silver bullet for everything. We actually had a scope to say, this is what we need to focus on, because if we do all these things correctly, this is where our baseline is, and this is what we need to do. There's some tabs on there. There's video materials, so if you're trying to work with a team, we've got training modules, which we're going to play on in a moment. There's downloadable documents. as well, PowerPoint slides. There's a whole range of resources that can enable you to run your project, including there's an end-to-end guide to run that whole sequence I just talked about. There's an end-to-end guide for even facilitation. So if you need some help from, say, a consultant to help you, they're not bringing the process. You've got the process. They just need to help you work your way through it. It's been industry validated. We've run 4 global workshops now with the ICMM out of London, and we've had 16 major mining companies send their people, and we've worked through that whole sequence of events and the materials and how it works. And you know, years ago we were all a bit tentative about how good is this? Is it working for everybody? Well, the resounding issue now is it does work, and if you follow it, you're probably going to go okay. So we would encourage you to go and have a look at these resources. You don't have to reinvent the wheel, and you can learn from others. And it's going to continually be updated as we learn more. I'm just going to show you one example. This is an incident investigation tool that's come out of the baseline. So if you understand all of your baseline, you have an incident. What it allows you to do is say, hey, I've lost this situation. You know, there was speed and clearance were involved. How did I lose that? What were the erosion factors that led to me losing that situation? And then what were the things in my management system that are meant to not let that erosion factor occur? And what this does for an investigation team is actually lead you through that pretty quickly. Move away from opinion to maybe a bit more fact. And the people that we've tested this on so far are pretty excited about it, the ones that have seen it. So this is a great creation of Eve up the back there. She did a lot of this.
Welcome to the Immersed Vehicle Interaction Operational Effectiveness Learning Module 6. This module focuses on the Vehicle Interaction Incident Contributing Erosion Factors Assessment tool. The tool can help you investigate vehicle interaction incidents effectively. The module is provided free of charge and is not for sale or rent. All content is copyrighted by Immersed. Immersed is a global safety by design initiative established by mining companies to identify and close the functional performance expectations gap between earth-moving equipment users and equipment designers. This module has 6 elements: initial insights, the module purpose, the workbook, the operational requirement elements, how to navigate the incident contributing erosion factors assessment tool, and the vehicle interaction improvement body of knowledge. The tool offers a structured starting point for understanding the loss of operational requirements in an incident, identifying the contributing erosion factors, and determining the relevant causal pathways that may have contributed to the initiation of the unwanted event. The purpose of the module is to provide you with a tutorial on navigating and using the Incident Contributing Erosion Factors Assessment tool and to develop an initial understanding of the incident using the structured assessment steps. The workbook includes the Vehicle Interaction Baseline Operational Effectiveness Validation Process and the Vehicle Interaction Incident Contributing Erosion Factors Assessment tool. With the workbook opened, click the arrow next to the Incident Contributing Erosion Factors Assessment tool title. There are 13 operational requirements in the workbook, and each is specifiable, measurable, and auditable. Each includes a number, title, classification. Classification types include: an act is a human action to do something, for example, operator maintains adequate clearance distances. An object is a material thing, an engineering device that works independently of human action, for example, haul road berm. And a technological system is a combination of an act and an object which changes state to provide information for the operator to act on. For example, a low steering or brake pressure alarm. The operational requirements headings also include a description and objective. And is this operational requirement relevant to the incident question? The last column is the erosion factor incident assessment link. Let's walk through the steps of the incident assessment process. We begin by reviewing each operational requirement, its title, description, and objective. This helps us understand the context and relevance of each operational requirement to the incident. Next, in the column labeled, "Is this operational requirement relevant to the incident?" click the drop-down arrow and select either Yes or No. Work through all 13 operational requirements, making your selection for each one. For this tutorial, we've selected give way and speed as examples. To focus on your selection, use the filter option to display only the operational requirements you've marked as relevant by selecting Yes. This gives you a clear visual of the requirements tied to the incident. Now click on the Start Assessment link. This will take you to the erosion factors associated with the selected operational requirement. Go through each erosion factor and identify those that are relevant to the incident. For each erosion factor, review the list of causal pathway and select all that apply. Once you've completed this step, click on the Operational Requirements tab in the main menu on the left-hand side of the screen. Then click Start Assessment for the next operational requirement you selected earlier. Repeat the same process by reviewing erosion factors and selecting the relevant causal pathway. After both assessments are complete, use the filter option to display only the causal pathways you've marked as relevant to the incident by selecting Yes. This will give you a visual overview of the erosion factors and associated causal pathways that contributed to the unwanted incident. To take a deeper dive, you can review the baseline management sheets available on the home screen in this workbook. Use the reference number linked to each erosion factor to guide your review. Keep in mind that a single erosion factor may apply to multiple operational requirements, so you only need to review each erosion factor once. This module is part of a broader learning pathway. Additional modules and related industry resources are available through the Vehicle Interaction Improvement body of knowledge on the Immersed website. For updates and more resources, follow Immersed on LinkedIn or visit the website. If you have questions, reach out to Immersed via the email address.
You know, if you've been involved in incident investigation, the first thing we always do is look for the contributing factors and then try to drill upstream into your management systems. The ironic thing we found when we did this work 10 years ago, 12 years ago, was the fact that when you looked at the risk assessments we did and all the other investigative tools at the start, we weren't capturing any of the erosion factors. We weren't referencing them, but the first thing we did in an incident was reference them. So what we've done now is this is an industry validated, tested and controlled set of information that's become very static. We're not constantly changing this thing. It's repeatable and reliable in that context. So I'm going to move on, but there's a whole bunch of those and it's free. All of it's free, yeah. And we want it used by industry. As I said earlier, what we're trying to do is empower you guys to make better decisions. And the more information you have and the more understanding about the things, it's really important. Vehicle interaction is really highly dynamic. That's because of the human factors. It's highly complex because of human factors. And it's not linear in its thinking. A lot of our safety assessment tools are, like I go to board a truck, it's 3 points of contact. It's all, I can assess that with certain tools that we've got. When you get into vehicle interaction, those tools just don't stack up. They just don't handle the complexity, the dynamic nature of it. So just to finish off, we've got where's the website? It's already done. Okay, so we're all done. Thank you. Eve in the front row here has been a coordinator with us for a long, long time, and she's retiring at Christmas. And this piece of work that she's been doing, I just want to publicly thank you for your efforts, Eve. You've been a marvel. We've got all lots of input, but you've actually made it come alive. So thank you for that. And as Eve said, it's free. We'd encourage you to use it. Thanks, Neil. Thank you, Robin. Thank you, Craig. Immersed is always on about not the solution. We're about defining the problem. And if everyone truly understands the problem and aligns to it, we're probably going to be able to work on, so people can go away and work on solutions. Although we've had Craig up here today from Wabtec, and he's been very active with the Immerse group, as a lot of the suppliers are in our working group. So I think we've got 270 people on our vehicle interaction working group from all around the world that dial in. Immersed is not trying to back a winner in one product or another. We see that it's about constantly leapfrogging each other. And there's no best practice. You're only ever leading at one point in time. So right now we've done some work and it's been good work. We'd love to see people take that further and better than the work that we've done. And we'd like to see it across more and more of the suppliers because there's lots to do and there's lots of mining going on out there. So with a minute to go, one last chance in the audience. Has anybody got any questions or anything they'd like to say? If not, we've kept to the time schedule and we'll give you 30 seconds back. Thanks, Dimitri.